So this is the Sputnik Modular Dual Oscillator. And what we have here is two generators or oscillators with a modulation bus between them, and then a wave shaper or wave folder, depending on how you've got it set with these harmonic controls up here. And this kind of design and this philosophy and way of working comes from the Buchla philosophy or West Coast philosophy. And in that, we start with a simple waveform, so a sine wave, and then through a process of modulation, or wave folding, or wave shaping, we can create much more interesting and complex waveforms. So let's have a look at the features of the dual oscillator. Both oscillators have coarse and fine tuning. They both have a volt per octave input, and then moving down they both have a bipolar CV input. So moving on, generator 1 has got 3 waveform outputs, triangle, sawtooth and square. So let's just have a look at those. There's the triangle, very much as a triangle should be. Sawtooth and square. Moving on, both of the generators or oscillators have a frequency modulation input, so you can externally frequency modulate them, as well as being able to do frequency modulation of number 2 by number 1 through the modulation bus here. So we also have sync on both of these oscillators. However, they're both slightly different. Generator 1 can be soft synced via this switch to generator number 2. So let's just hear what that sounds like. Generator 2 can be synced via this external sync input here, and we've got an attenuator knob to control the amount of sync going in. But if we wanted to sync number 2 to number 1, we could take the square output of generator number 1, put that into this sync input here, and then listen to the final output. So moving on again, we're onto this modulation bus, and this is kind of one of the most interesting features of this kind of dual oscillator Buchla setup sort of thing. So if we listen to the final output of number 2, we have amplitude modulation, which at LFO rates is essentially tremolo. But as we move up into the audio rates, we get really interesting shapes being made. But it's really quite smooth. It's not like other amplitude modulation that I've done with other VCAs. It's quite harsh, but this is quite smooth. And obviously all these modulation types are dependent on the wave that you've got selected. So each different wave gives a different tone to your modulation. So here's an amplitude modulation patch. Externally, I was trying to do as little as possible. So all we've got going on externally is a MIDI to CV converter, an envelope, and a VCA. The VCA is just opening and closing on the triggered envelope from the MIDI to CV converter. So when I play a note, it triggers an envelope, which opens and closes my VCA on the final output of generator number 2. The envelope, which is triggered by the MIDI to CV converter, is then split to control a couple of modulations within the oscillator. And then we've got a negative envelope on the pitch of modulating the pitch of generator number 1. So as I play a note, the envelope opens, and as the attack raises, the pitch of the generator number 1 will go down. So you can just see that now. And obviously, as I release the note, the pitch jumps back up to its original pitch. That envelope is then split to control the amount of timbre. So we're positively raising the timbre amount with the envelope. So as it opens, it raises the timbre, and then as the envelope closes, it reduces it back down to what it originally is, which at the moment is 0. We've then got the CV output of generator number 1 going to control the harmonics, the low and high order of harmonics. So if I just take that out, and then you can hear. And then hear it with it in. So you can see by a relatively small amount of external modulation, you can get a pretty dense sounding patch, even if it's maybe not that dense. Moving on to frequency modulation. At LFO rates, we can do kind of standard pitch modulation stuff. But obviously at audio rates we get different tones again. So here we have an FM bass patch. If we just start listening to that. Obviously we can change the wave of the FM to see what difference in tone that makes. Externally, what we've got going on is the output of my second generator is input into the Borg filter. We've got a bass line coming from Rene, and then we've just got some tempo synced LFOs and triggered envelopes from the Abstract Data Octo controller. So first up, let's hear what the so that's a bit of the timbre control, and on the first beat we've got this inverted envelope to turn down the amount of timbre, and then we've got tempo synced LFO input into the order of harmonics too. And obviously when we put it through the low pass gate, Borg filter in low pass gate mode, it's just acting as a VCA, but because we've got this tempo synced envelope reducing the amount of timbre, we get a clean sine wave on the first beat of the bar, and that almost sounds like a kick drum. At the moment, obviously, the generator 1 isn't getting any pitch modulation, so if we split the pitch coming from relay into generator 2 and into generator number 1. That will bring the harmonics closer, and you get a different tone of frequency modulation. So let's just hear that. So obviously it's static, and then we can sync it as well, so it's even closer. So then we've also got the sawtooth output on this selected output here, and that's going to go into the Borg filter as well. So you can hear that. So obviously at the moment it's synced, and obviously this oscillator is tuned at an interval. And then I've got a pitch modulation on this first oscillator to kind of give, I guess, a little pitched kind of snare sort of feel. So almost getting like a kind of drum voice out of this bass line by using tempo synced envelopes. So finally on this modulation bus we have Tombruh Control here. So if we introduce that, you can hear essentially what we've got going on is modulation of this control over here via generator number 1. So if we introduce that at LFO rates, you can see that it just basically turns the wave folder or Tombruh Control on or off. But as we move into the audio range, it gets really quite brutal. So on this modulation bus we've got an amount knob, and then we've got a bipolar CV input for the amount. So this patch was built to kind of demonstrate the extent of tone that you can get out of this oscillator when you're using modulation, and how you can start with something really basic like just a sine wave, and then by introducing the modulation you get all these kind of crazy tones out of it. So first up, this is the oscillator number 2, obviously just a sine wave. I've got a little bit of reverb as well, just because if you're doing a drone you need reverb, I think. So that's my my second generator there. I'm going to introduce the first generator, which is just, as you can see, has got no pitch, has got no note information going to it, so it's just a static note. And then I'm going to sync number 1 to number 2. And then I'm just going to start bringing in some of the other modulations. So here I've got the sine wave output of generator number 2 is frequency modulating generator number 1. And then I'm going to introduce some of this modulation bus. So we've got timbre modulation and amplitude modulation. And then we've got an envelope, which I'm just going to use to turn that down on the first beat of the and then I've got an envelope and on the opposite side, turning up the timbre. And then I've got a tempo synced LFO, ramp wave LFO from the abstract data octo controller, going to go into the harmonics. And these two waves are just being mixed, and then they're going out to my mixer, which is providing some reverb. But I can turn that reverb off if you want to hear the dry waves. Drastically kind of change how your patch is sounding by swapping around these attenuators. It's really useful. So, as I've said, you can start, and without having to really patch anything, you can just kind of coax kind of different tones out of this oscillator. And obviously I'm not using a filter or anything, I'm literally just listening to the final output and then this selected output of generator 1 and 2. Moving on to kind of my favourite or the most interesting part of this oscillator is this wave folder, timbre and harmonics section. So we hear that by listening to the final output of generator number 2. So once again, you can see we start with a really beautiful pure sine wave, and then by introducing some of this timbre control, you can see that the wave starts to fold on itself. You get all these lovely kinks, and subsequently you get a different wave shape. Moving up into this harmonic section, adjusting this symmetry control, you can get a different tone of wave. So you can see that just slightly changed the shape. And then this order of harmonics allows you to move more into kind of regular shape. So that's kind of like a kinked square wave. And then if we move down into the even harmonics, we get kind of a kinked sawtooth. Or we can have a mixture of the two. Both of these controls have a CV input, and the timbre control has a bipolar CV input over the amount. Finally, we've got 3 different outputs on each of the 2 oscillators. The first oscillator, we've got this CV output, which is a 0 to 5 volt output of the selected wave that we have here, and that's really useful for modulation within your system. We then have this triangle output, which is just a straight triangle, always the same. And then coming down to output number 2 for the generator number 2, we've got a square output. So this is completely unaffected by the timbre and harmonics controls. And that's the same for this sine wave output as well. It's also unaffected by the amplitude modulation and the timbre modulation, obviously. So it's really useful for a modulation source or an FM source within your system. So what is my opinion on the dual oscillator? Personally, sound quality wise, I really don't think you can fault it at all. I think it sounds awesome, and the range of tone that you can get out of it and the quality of the tones that you get out of it is really, really nice. And if this is kind of half as good or 2/3 as good as a Buchla oscillator, then you're paying too much for a Buchla oscillator. Get a Euro system and get one of these things in it. There's a couple of things. I don't know if it's meant to do this, but so this frequency modulation input, when there's nothing input into it, you get an increase in pitch there, which kind of seems, I don't know, maybe it is supposed to do that because it does that on both of the frequency modulation inputs. The other thing that I noticed is that when you've got a modulation into this CV input, even when it's centered, because it's got a little center pin notch there, I'm still getting some modulation, and that could be, maybe that's probably a little bit irritating, because obviously if it's on the center dent, you kind of want it to be, you want there to be no modulation. But again, maybe it's supposed to do that, but it doesn't do that, I don't think, on the Tombruh Control. So the Tombruh Control is completely is in the center pin, center dent, and we're not getting any modulation. Other than that, yeah, as I said, I don't really think you can fault it. And the price that you get on this is kind of reflected by the components that they've used. You know, it's like plastic shafts, so the pots aren't completely sturdy, but I don't think that's really really that much of an issue. It feels fine to use, and these switches aren't the best, but I think they do the job perfectly fine. So yeah, overall, I think it's a really, really, really nice oscillator. It sounds great, and the range of tones and harmonics that you can get out of it is really impressive. So it's 425, I think, UK pounds, and the US and euros will scroll along the bottom.